Hey everybody, this is Scott from the ThreeFold team. Today I've got a presentation about data and data sources on the ThreeFold grid. I'm not going to be talking about how you can store data within deployments or applications running on the grid. Instead, I'm going to be talking about the data that makes the grid itself work. Things like farms, nodes, and contracts about deployments, and things like that. Bits and bytes for today. First of all, what is a computer network? Because ultimately the ThreeFold grid is a computer network. It's made up of hardware, software, and data. These are the essential components, and of course people that use the network. In our case, our hardware are the nodes run by farmers, as well as the computers that run TF chains, some of which are part of the grid and some of which are not. We also have software, so this is the TF chain software as well as ZeroOS, and then some additional software on the side that makes things work, but those are the two really essential components. And then we also have data, and again this is things like farm IDs, nodes, node IDs, stuff about the entities that make up the grid, as well as some data about deployments and users. On the grid, our data stores are the nodes and TF chain. So these are the two ultimate sources of truth, and everything that we need to know about ThreeFold grid we can learn from these sources, and if we are submitting some data to the grid, we will be submitting it to one of these places. People access data through applications like the Explorer, the Portal, the Playground. And blockchains are not a great data source. So TF chain is a blockchain. It's a replicated state machine that's able to form consensus about transactions, including updates to a database maintained by TF chain. So we have both TFT token transactions as well as updates, again, to things like farms. So a farmer wants to change the name of their farm, they can update this on TF chain. TF chain is responsible for forming consensus about the state of that data. But when we want to go and query data, the blockchain in itself is not a great data source. It's the authoritative data source, but it's not a great place to go and run searches and do things like this. So instead, we typically use middleware. The middleware ingests the data from TF chain and presents it in a way that's much more searchable and accessible for both for software and for humans. Finally, at the end of this presentation, we're going to build a quick web application that uses data from the grid, queries some data from the grid based on user input, and displays it back. This is going to be a super simple thing with just a little bit of code. Overall, this presentation isn't super technical. It's more of a architectural overview. With that in mind, let's take a look at how the grid is put together from a very high level. So we have people, we have TF chain, and we have the three nodes on the grid, all communicating in a bidirectional flow of data. So each of these entities is communicating with the other two, and they're both exchanging data back and forth. I'm going to be using these arrows that you see on a couple of the future slides too. The arrows just indicate which direction the data is flowing. So for example, people might want to send some data to be stored in TF chain, for example, when they register a new farm or create a contract. They might send deployment data to the nodes, again, when they're making a deployment. And the nodes are going to store their uptime reports on TF chain and also query TF chain for purposes like finding out whether they've already been registered and have a twin and a node ID and things like that. So this is the top level. Of course, in practice, like I said, we're going to have some middleware that's sitting in here to go between TF chain and people to make that process more efficient. We're also going to have some middleware working in the form of the grid proxy in here between people and nodes, but overall this is what the grid looks like. These are the fundamental top-level components. Here is the Polkadot UI, which there's a lot happening on screen. I'll get to that in a second. Polkadot UI is a very cool thing that we get kind of for free with TF-Chain because it's based on Substrate, which is a framework for building blockchains in the Polkadot ecosystem. So we're able to take our TF-Chain URL endpoint and put it into this website, the Polkadot.js project. They create this Polkadot UI. And once we input that URL, it's going to allow us to query TF-Chain and also submit transactions to it, which we could sign with our Polkadot browser extension like we do in the portal. This example is showing how we query data about a farm from TF-Chain. So we can see here we're using the grid module and the function is farms. We're inputting the farm ID number 13. This happens to be my farm. And down below here we can see the name of the farm, the twin ID it belongs to, whether or not it has public IPs, and some other kind of back-end data that the grid uses. So this is okay. We have most of the data that we would want to see about a farm here. But the thing is, we can only query one farm at a time by entering its farm ID. So if we happen to know the name of the farm, we can actually go to a different function here. We can put in the name. It's going to come back with the farm ID. Then we come back here, input the farm ID, and get out the data about that farm. So that's okay, but if we wanted to run a more complicated kind of query, for example, find all the farms that have public IPs available, in that case, TF-Chain doesn't have any built-in functions that return, say, a list of farms with public IPs. Instead, we basically have to go through each farm one by one, check farm number 1, check farm number 2, and make a list of all farms that have public IPs. That's obviously not very convenient, and that's why we have middleware that allows us to run those kinds of queries. And this is what the middleware stack looks like. So in the middle here is the stack with TF-Chain, GraphQL, and the Grid Proxy. Data flows up the stack, so GraphQL is ingesting the data from TF-Chain. It's allowing us to form the kinds of queries we were just talking about. And then the Grid Proxy is periodically pulling in a subset of data that GraphQL makes available and serving it over a REST API, which we'll see later. Now, in the lower left here, we have Polkadot UI, which we can see is has a two-way data relationship with the TF-Chain directly, and those limitations that we discussed earlier. Here we also see our nodes are exchanging data with TF-Chain, like we saw in the architecture overview. Our nodes are also sending some data through the Grid Proxy to the Explorer. This is in kind of a special case where we use the Explorer to query the real-time status of a node. Now, for example, if we open the Explorer and we want to see all the nodes in a given farm, it's going to go first to the Grid Proxy to get that information. And Grid Proxy can also tell us whether or not that node is online or has been online within about the last 40 minutes. It was previously every 2 hours that the nodes report uptime. Now it's 40 minutes. So that's what we'll see in the list view. The nodes have a status, online or offline. But if we select a node, the Explorer will ask Grid Proxy to query the node for real-time node status. It does this using the reliable message bus over the planetary network. And the reason we need the Grid Proxy here is that the Explorer, which is just an application running in your browser in JavaScript, doesn't have a reliable message bus client running, and it's not able to connect directly to the nodes over planetary network. It's possible that this will be changing due to some architectural changes of the grid, but for right now, the Explorer relies on the grid proxy for real-time node status, but for most of the information in the Explorer, it's coming directly from the grid proxy. This is information about the farms and the nodes, public IPs, things like that. Finally, down here in the lower right, we have the portal. Now, the portal is another application that can show us information about nodes, specifically for a farmer. So a farmer can go in, they can see actually a bit more data on their nodes than shows up in the Explorer. Specifically, they're able to see the uptime of their node as a percentage of the current month. And this is kind of a newer feature that we have. Previously, you could only see how long a node had been online since it last rebooted. In order to do this, the portal is also pulling data from GraphQL about the uptime events that have been submitted by the nodes to TF-Chain. Again, that data is ingested by GraphQL. The portal is able to query that, process it, and present us with a percentage view of the amount of uptime that the node has for the month. And the portal also can submit data, can submit transactions to TF-Chain on behalf of the user. Again, this is when you create a twin, you create a farm, or update any data about your farm, and that gets submitted directly to TF-Chain through the portal web application. So this is the middleware stack and a couple of examples of how it works in a process. So let's take a look now at the playground. The playground is another application that makes use of the middleware stack, and it also pulls data both from the grid proxy and the GraphQL as needed. So grid proxy doesn't have any information about contracts, it's really just about farms and nodes. So GraphQL is where the playground would go for information about contracts on the grid. The playground also needs to submit data to the nodes when deployments are created. This is the bulk of the deployment data gets sent directly to the node in an encrypted format. So this can include secrets, and the playground can also query data back from the nodes. So if you open up the playground kind of in a fresh way and you load up your account, it's able to get that workload data back from the node, take the contract data from GraphQL, and then it can give you a complete view of any deployments that are associated with that twin that's associated with the TF-Chain mnemonic seed phrase that you inserted into the playground. When the playground creates a deployment on your behalf, it also needs to authorize a contract for billing on TF-Chain. So this is where we see flow of data from playground to TF-Chain when those transactions are submitted. So in this case, the playground is interacting with all three layers of the stack, but it's only querying data from GraphQL and from the grid proxy. We're not querying directly from TF-Chain in this case. Let's take a look at GraphQL and how it gives us more functionality than the Polkadot UI, which we saw earlier. So, for example, if we wanted to find all of the farms on the grid, on mainnet in this case, I should note that, there's a separate stack for testnet, mainnet, devnet, and QAnet. In this case, we're looking at mainnet. And on the left here, we have a query where we're looking for farms, where the name contains the word duck, and we want to know the farm ID, the farm name, the twin ID, and information about any public IPs that are associated with this farm. On the right, we have the result that's returned from GraphQL. We see there's two farms with the word duck in the name, Duck World and Duck Pond. We see their farm ID and the twin ID that is the owner of these farms. So this is cool. This has given us some additional functionality. that we can use to satisfy our curiosity about what is going on in the grid in terms of farms and nodes. Next, let's check out the grid proxy. So grid proxy, again, it is querying GraphQL and caching some of the data, making it available in a way that's more appropriate for high volume applications, so it can take some load off of GraphQL. And we can actually run the same query here in the grid proxy just by typing this into our browser. So gridproxy.grid.tf/farms, this is the farms endpoint, and then put the question mark, and our query here is name contains duck. Now in this case, we're going to see 4 farms returned because this is a case-insensitive query, so we're also going to see a couple farms that have a capital D for the duck. And then we're going to see a standard set of data that's returned by grid proxy, including the farm ID, twin ID, pricing policy, certification, the stellar payout address, whether or not it's dedicated node, and any public IPs. So these data fields are all available within GraphQL as well. I didn't select all of them, but these are standard. So when we use the grid proxy, we're not choosing which fields we want to return about the farms that match our query. We just get the data that grid proxy has on each, and we can sort through that later if we want to. Brief intermezzo here. Some of you Scrooges and Fudsters may be wondering, aren't these services centralized? Well, yes, they are. These are centralized services that are operated by ThreeFold to support the interfaces that we also offer, like the portal, the Explorer, and the Playground. The portal, the Explorer, and the Playground are just applications that run in your browser, but GraphQL and Grid Proxy are separate servers that are hosted by ThreeFold that are required to make these applications work. So yes, these are centralized, but you're free to run your own. The code for GraphQL and for the Grid Proxy is open source and freely available, as are the deployment specifications. So anyone can run their own, and there's no need for these to remain centralized if anyone sees that as an issue. You can also run your own TF chain node and have that full stack, or you could run your own kind of indexer. You don't have to use the same kind of GraphQL that we use. So there's a lot of options there for anyone that's concerned about centralization or is concerned that these services might have an interruption that could interfere with something that you're building on the grid. So if you need those kinds of assurances, you can run your own stack, and you could also offer that to other people as a way to decentralize the grid as a service too, if you wanted to. All right then, moving on. How can we build something with these tools? Quickly and briefly. I'm not a great web developer, so I basically just looked up some examples on the internet, copied and pasted them, and made some changes so that they can be a suitable example for us. So let's check it out. This is the HTML for a very simple web application. We have a label, indicates that we're taking in a farm ID. We have an input field, you'll see down below, and we have a button that says submit. And here's something important. When we click this button, it's going to call a function for us in our JavaScript script that we'll see on the next slide. Then down below we have another label, indicates we're going to see the nodes that are in this farm. And then we have this div, which is where we're going to stick our response. For now it's empty, but we're going to insert our text there in the script. So here's the script, and there's kind of a lot going on here. Let's break it down. So when we come into it, we're going to specify as XHTTP thing, which is what's going to allow us to query the grid proxy and get back the data that we want. This farm variable is just pulling in the contents of our field. In this case, we're expecting the user to submit a number that corresponds to a farm ID. We're not doing any checking, so they could put in something that wouldn't work and that would break it. But for this simple example, we're assuming that we're getting a number, which is a farm ID. And let's jump down here. So we're going to take that number and we're just going to glue it on to the end of a URL that we've already specified here, like we saw before, but this one is a nodes endpoint and our query is for farm IDs. And we're going to equal that to whatever farm ID our user enters just by, again, gluing those together. We're going to run that request like we did by putting it into our browser bar. We're going to run it, and then when the response comes back, we're going to take that response, bring it into another variable called nodes, and then for each item in the list, nodes is going to be a list, for each item in the list, we're going to extract the node ID and add it to a string of text with a space in between each one. So we're going to take each node ID, we're going to put a space between them, and then finally we're going to take that result, this string of text that has all of our node IDs in it, and we're going to insert it into that response div that we had earlier, our blank div. We're going to set its inner contents equal to this text. So how does it work? If I put in farm ID 13 and I click the submit button, it's going to query the grid proxy. It's going to extract just the node IDs from that response that we get, and it's going to insert them here in the div. And we can see that there's two nodes in this farm, 3995 and 4550. So this is a very, very basic sketch of how you can create an application that relies on the middleware to take some user input and create some output. And our Explorer is basically a really fancy version of what you're seeing here with more features, but the underlying concept is essentially the same. All right, let's review. So the grid, again, is people, nodes, and TF chain, each exchanging data with the other two in a two-way fashion. We have middleware that helps make data available and also manage load on the grid. Our nodes are storing workload data, and they can also report on their state. So we can query nodes to find out things like how many workloads they're currently running and what percentage of their resources are consumed. And that's really all there is to it. The ThreeFold Grid is a complex system, but from a high level, we really just have these three components and some supporting elements, some supporting systems that allow us to do everything that we do on the grid with deployments and farms and nodes and all of that. And if you want to get started building applications that take data from these sources and do something interesting with it, you have now seen kind of everything you need to know to get started. A couple final things I want to mention. I was inspired to make this video because somebody asked in the chat, is there an API for the grid? And that's a great question. Now we've seen that there's kind of three different places where you might want to query data, and for what kind of circumstances each of those are appropriate. And I also want to mention that the reason that I'm familiar with this isn't just because I work with the grid and need to help people out and explain how it works and things like this, but also because I've built some things that use these data sources, so I had to get familiar with them. The main example being the farmer bot, the status bot for farmers, not the coming farmer bot for power management, but this Telegram bot that can alert you when your node goes down. And in order to build this, I needed to get data from GraphQL and data from the Grid Proxy, and I also needed to be able to query the real-time status of nodes and be able to report all of this back to the users of the bot. So if you're ever curious about that and how it works, these are the tools that it relies on, and it's just a matter of connecting these things together in the right way to create the output that your users are looking for. So again, I'm Scott from the ThreeFold team. If you have any questions about what you saw in this video, please feel free to reach out to me on Telegram, or tag me in the forum, or email me, scott@threefold.io. I'd love to help you out, point you towards any relevant documentation or repositories that you might need. And yeah, so I hope this was helpful for you. I hope you take what you learned today, go and build something cool, and I'll see you next time.